let's take a look at how an advanced programmer might approach this problem. And I think the advanced approach is going to be much more willing to interrogate the modeling of the problem. If you think about a problem like this, there is some technical sophistication that is needed in order to solve this problem. There's an inherent complexity to these things. And we may not be able to get away with that complexity. We may not just be able to say, look, let's not consider that some people were there for the drinks and some people were there for the meal. Let's just lump it all together. Well, the whole motivating example is to make sure that the person who shows up late doesn't have to pay the outrageous drinks bill. And so we're forced to have some technical sophistication in order to solve that part of the problem. That is a fixed requirement from our stakeholders. Well, an advanced user may think, can I take that technical sophistication? I can move it around. And maybe I can move it around to support better ease of use, more flexibility in this code, greater correctness in this code, maybe even greater testability in this code, maybe in exchange for greater technical sophistication in terms of the logic in the code itself. And so our advanced user here has decided to model this program very, very differently. Instead of having one singular function that computes the entirety of the payments given the entirety of the bill, our advanced user has said, you know what, I'm more comfortable with the technical sophistication of mechanisms such as generator coroutines. I'm going to write a generator coroutine. And my generator coroutine is going to take each order that a user has one at a time and return or yield from this generator coroutine what the payments would be up to that point in time distributed among my individual users. The advanced user said, you know what, the non-determinism of this problem also introduces a modality, or also is related to, I should say, a modality here. If there's a remainder on the bar tab and a remainder on the table tab, we know for certain that remainder is only going to be a couple of cents. Should it be the case that that remainder is allocated to just the people who paid the bar tab for the bar tab, or just the people who paid the table? Or could it be the case that we could just lump that remainder all together and just assign it to one person? At most, it's going to be the number of guests times the number of portions of the bill in cents minus 1. So we're talking only a couple of cents in total, not a lot of money. We could just lump it into one person. Or we could have other policies associated with this. We could say, you know what, if you show up late, you have to pay the extra 1 cent. There could be other modalities here. And the advanced user said, you know what, I'm not even going to bother with those modalities at all. I won't model them. I'll remove any non-determinism. I will return the payments and the remainders in each iteration of this generator coroutine, and I will let the end user decide how they want to allocate those. And in this case, you can see this end user has decided to allocate the entirety of the remainder to one person, saying, you know what, it's not so bad. Charlie, I know, showed up late, but he can get the extra 1 cent from the bar bill. It really isn't that much of an imposition as long as he doesn't get the rest of the bar bill. Additionally, the advanced user has said, you know what, I prefer a much simpler modeling on the orders because it makes it easier for somebody to use this. As long as they understand what a generator coroutine, there's a .send method, that .send method returns something. All I have to know is that I need to send in a tuple with the bare minimum of the information that's necessary, the guest, the account, and the amount. And it'll give me the payments and the remainders. And you can see we actually get some additional functionality out of this. Specifically, we can see how the bill is split up over time. We might even be able to argue that this gives us some additional correctness because from the way this code is written, Charlie can't pay any portion of the bill until Charlie shows up in the orders. And so as a consequence, up to this point, Charlie isn't even able to pay a portion of the bill. We could even do something in our use case logic for this. Specifically, we could add in another order that represents the reconciliation of the bill. And after Alice and Bob have waited for a little bit and are ready to be seated, we could then reconcile the bill, start it over at 0, and then have Charlie further order. In fact, if we chose to do that, we might not even need to model this portion of the bill. We could have an even simpler input, just the unique identifier for the entity who's responsible for paying and the payment they have. And when we've decided, okay, that portion of the bill is over, we just send into this coroutine some kind of payment that, or some kind of part of the order that represents a reconciliation. And so that should net out everything, and then we can maybe remove that at the end or some mechanism of that nature. As a consequence of this, we end up needing a slightly more complicated test. We need to use some sophisticated functionality of hypothesis in this case, a composite test where we randomly decide who the guests are, we randomly decide who the accounts are, and then we draw iterables of these order objects. Note, one nice thing about this code is we don't need to use this order object at all. Here, it's using it more or less after the fact, after defining the data, but the signature of this generator coroutine is, give me a tuple of 3 entries, and I'll give you 2 dictionaries back. And so it's a very, very simple API. Well, with this, we can test quite a few different things. This logic is not altogether too dissimilar from the logic in the code itself, so we might need to think a bit about if we can improve this test here. Although part of this logic here is just tracking how many orders we've seen, how many guests we've seen, because we're not guaranteed that the sequence of orders is finite anymore. And so, of course, we may not know all of those up ahead of time, so we may need to track those as we go. And we can test some simple details of this code. For example, if the restaurant got all the money they were owed, as well as that the total remainder was always less than all the guests times all the accounts. So that remainder, irrespective of how we distribute it, is never going to be that much money. And so we may be free to use any policy. But as always, the advanced solution may be one that really is advanced only in how it rearranges the complexity or the technical sophistication of this problem that achieves the best business outcome. And so in truth, if we really think about this, maybe the case is that irrespective of who's at dinner, irrespective of where the payments and the orders come up, just give me the bill. It makes everything easier. I'm going to pay for it in the end anyway. As you can see, there are many different ways to solve even a slightly more complicated problem of splitting a bill like this, where we want to allocate parts of the bill to the people who are there for the bill. And there's a lot that we can learn by iterating through different solutions and thinking how those solutions address the question of modeling as well as the question of testing. Thank you all for joining us for this session. I encourage you to subscribe to our YouTube channel so that you'll know when these sessions are coming up. In our next version of this problem, we're going to look at an incredibly sophisticated problem that's going to require a different approach to testing than the testing that we've seen here. Specifically, we're going to try and write some testing that looks at, is a policy for how the code should operate satisfied, even if the actual outputs may change as somebody updates a heuristic for how that policy may operate. I'd really love to see you there for that session. Thank you all for joining us, and we'll see you all next time.
Thanks for watching. If you enjoyed this video, give it a like, hit subscribe, and check out the recommended video on the screen. See you in the next one.